call it a quantitative. Inertia is a quantitative measure of the quantitative measure of inertia is mass. What do we mean by that? We mean by that an object's mass is what determines its inertia. Okay? It doesn't matter its state of motion, whether it's in motion, whether it's moving at 100 miles an hour, whether it's.
All right, I'm back. What up? What up? What up? What up? What up? What up?
It depends how much inertia something has. Its mass. That's all. So an object. So 100. Sometimes I'll use, like I said, I'll use the old units that we're used to, like pounds. So just for examples. So if you have a 100-pound rock, a 5-pound rock, how much is it going to take? And they're both at rest. How much it's going to take? It's going to require more force to move the 100-pound rock than it is the circle. The 100-pound rock has more inertia. And likewise, if they're both in motion, they're both at constant velocity. How much force is going to take more force to change the velocity of the 100-pound rock than it is the 5-pound rock? Yes. Yeah. Say both in motion. How much it's going to require more force to bring the 100-pound rock to the rest. Okay, so here's a cute example.
What the fuck can I bring it? What?
Okay, so this manatee, it's just moving at a constant velocity in direct speed. Watch that again. Is it propelling itself forward at all? It's not. It has some velocity that it's already accelerated at previously, but it's not propelling itself. It's just moving on pure inertia. Okay? It's moving at a constant velocity, at speed and direction. Same speed and direction. Okay, so this is probably a better example than the one I was using about the two rocks. Okay, so we have two objects. They both have the same size, the same volume, same dimensions, but they have they're different masses. One's wood and one's lead. Okay. So the one that requires more force to move is the one that has the larger mass and hence the more inertia. So the lead block is going to resist changes to its state of motion more than the wood block. Okay. Or in other words, it's going to require more force to change the state of motion of a lead block. Wood block. So the lead block has more inertia, hence more mass.
There we go. That's what I'm watching.
So here are a few examples of inertia. The first one I've never really experienced is supposedly if when you're descending in an elevator and the elevator comes to stop quickly, you feel lightheaded because the solid structure of your body, your bones and your flesh come to a stop. Blood is liquid, so it's moving. I've never really experienced this. Maybe some of you have, but
yeah, but like you see everything else, right?
Let's skip the second one. And the third one: headrests are installed in cars to prevent whiplash injury.
You should see my fake desk. You should see me right here. You should see the stream below.
Your head is not going to move in sync with the rest of your body. Your head's going to stay, and your body's going to go forward. Okay, so that's why we have a headrest. Headrests basically just extend your seat so that your head and body move together.
You do see the stream below too. You see my camera as well, right?
Riding a bicycle, riding a bike, and you hit it, and you hit a curb.
Yep. Okay.
You fly off the bike, and your object, and your bike is going to stop.
Think he's just trolling.
The curb will stop your bike. You will keep flying forward because your body wants to maintain your state of motion. You want to keep moving forward. The bike experienced an outside force to stop its state, to change its state of motion.
Yeah, that's what you should see.
Keep moving forward. And then the most tragic of all, the last one, coffee spills in a car when accelerating.
That's exactly what y'all should see. That's it. Right, the desk, me, background video, and then the video below me.
Car, you hit the gas, it's going to spill. Okay? It's the velocity. There's an acceleration. There's a change in velocity.
Would y'all rather me blow up the instructor talking?
However,
video, I'll do that.
A change in velocity can also mean a change in direction. Okay, so when you
I think I'll switch it out. I was gonna leave it on that, but I'll switch it.
You take a hard right turn or a hard left turn. What's going to happen? Well, your velocity changes because even though your speedometer is still doesn't change, you're still going, let's say, 15 miles an hour. Your direction suddenly changes, and that's a change in velocity. That counts as an acceleration. So that's going to spill. All right, we don't need to do this. This is kind of a lame. That's a lame. No, let's move on. Okay, let's move on to Newton's second law. So in all of science, I think if I were to tell you the most fundamental formula in all of science, I would say it's this: force equals mass times acceleration. Okay. This is Newton's second law of motion, sometimes called the law of acceleration. Force equals mass times acceleration. It relates the quantity of matter, which is mass. It relates mass to the acceleration it has. If a force acts on a mass, it relates its mass to the acceleration as a result of that force. So force equals mass times acceleration. So
Yeah. Right down.
Force equals mass.
I want to show everybody how handsome you are today.
Right,
Look
well,
how handsome I am.
I don't see more. Okay, well, force equals mass times acceleration, or acceleration equals force divided by mass. Okay, that's all I was going to write. You can just solve it. You take this formula on the screen and just solve for acceleration. Acceleration equals force divided by mass. So when looking at this picture, so we have three different masses in this image. We have a 1 kilogram mass, and then we have 2 of those kilograms. So we have 2 kilograms, and then at the bottom we're going to apply a force on 3 kilograms. So in each case, we're going to apply the same amount of force, just 1 Newton of force to each of the different masses. Okay, but they each experience different accelerations from that applied force. Okay. So you can see the relationship between applied force and acceleration because of mass. Okay, so the first one experiences an acceleration of 1 meters per second, but when we're applying that force to twice that mass, our acceleration gets cut in half. Okay? So we increase the mass by a factor of 2, then the acceleration decreases by a factor. And likewise, you apply that force to 3 times the mass, you're going to get 1/3 as much acceleration. So the same force with different masses agrees with force is mass. Okay. Or if we're just talking about F equals ma in that form.
Again, I don't know if y'all can see. Y'all can't really see him because he's behind my desk now. But this guy right here. Oh, you can't see that.
We see
my
that,
mouse. This guy right here next to this guy in the red shirt. Y'all can't see his laptop, but that dude's just been playing Minecraft the whole time. And then there's a guy that's sitting right here. You can barely see his jacket. This dude's literally just sitting here watching anime. I can't tell what anime he's watching though, but he's legit just been watching anime the whole time.
And so since force is a vector, we can break it down into its components, its y and z components. Same with the acceleration. Force and acceleration are both vectors. And so
yep.
These apply.
Oh, I know. He just doesn't seem to care. You know what I mean?
You can see that it's broken down into its x components. The net force.
And like this dude right here in the red just has been watching him play Minecraft the whole time too.
The y and z. Force equals mass times acceleration, and acceleration equals force divided by mass. Okay, so let's we can do a fun demonstration here with what we've learned so far. Okay, you guys familiar with this story, Spider-Man story? Okay.
Ground.
So Gwen.
Next. And then
So she falls. She falls from a bridge. So his girlfriend falls from a bridge, and to save her, he casts a net. And then as soon as she gets the net, or not the instant she gets the net, but when he's trying to break her fall with the spider web, and she dies. So we're going to use what we've learned so far to see what happened, to see what it is that happened where she didn't survive that fall. Okay, so but first we need to make some assumptions. We don't know everything happened, so we're just gonna So we're just gonna make some assumptions here. We're gonna say this is free fall. Okay, so when Gwen starts to fall, she's not experiencing air resistance. She's just gonna have a constant rate of
this guy.
acceleration at 9.8 meters.
Oh wait, this guy? Yeah, he does. Yep.
Okay, so
Same with this guy. He looks like he's writing some type of code. Same with this dude too.
So we're gonna say she's gonna fall
I'm gonna do this real
3/4 of the
quick so you
height
can
of that
see.
bridge.
Hold on.
Okay, so the height of the bridge is 604 feet.
Damn it.
That's 184 meters. So she's going. So the distance of her fall is going to be 3/4 of 184 meters. We're gonna say that she has
Now you can see.
weighs 110 pounds. That's 50 kilograms. Okay, that's not in newtons. Okay, so we're doing just like they do in other countries. We're not expressing the weight in newtons.
I'm trying to figure out what anime he's watching, bro.
50 kilograms. And
What anime is this guy watching?
probably the determining factor is that it takes we're going to assume that it takes a half a second for her to come to a stop. So the time it takes the first contact with the spider web to where she comes to a complete stop, her velocity is 0, about a half a second. Okay. And of course, you could probably already tell that's probably what does it. That is.
Here's Minecraft.
Okay, so let's just go through this. How long was the fall? We're going to say 3/4 of the length of the height of the bridge. So that would be 138 meters. Okay. So this formula, our initial velocity is 0, so v naught is 0, and x naught, our initial position, is 0. So that just leaves us with 1/2 9.8 times squared.
Uh-oh. What did I just do?
And so our final distance is 138 meters. So the displacement in the down direction is minus 138. So using that to solve for time, how long she was falling for, just solve for time. So if we solve for t, that gives us 5.3 seconds. So the length of the timing of the fall was she was falling for 5.3 seconds. Okay. Now how fast was she moving when she makes contact with the web? Okay. So we know that she's accelerating at 9.8 meters per second squared.
I was hoping there was a faster way to shrink this back down, but apparently there's fucking not. Oh, yes.
So
That's great.
maintain that acceleration. So when we replace 9.8 with we replace a acceleration with 9.8, then we can solve for v2. So v1 was 0. v2 is the time her velocity at the point where she makes contact with the web. Okay, so we're going to solve for v2. That's 51.94 meters per second. So what is 51.94 meters per second? We don't know what that is, right? In America, we don't know how fast that is. We need miles per hour. Okay, so I'll give it to you. That's 117 miles per hour. So after falling for 5.3 seconds, you're moving at about 117 miles an hour. Okay, now how much force? Now you remember, to change the velocity of an object, you have to apply a force. Okay, so there's a force that she undergoes, that she's experiencing when her velocity changes from 117 mile or 51.94 meters per second to 0. Okay, so how much force is required to bring an object to a stop? A 50 kilogram object to a stop. Okay, so let's use force equals mass times acceleration.
I'm Jay
what do we do
Murphy,
here?
sitting on the
F equals
back line
MA,
at Full Sail University.
And then we use M.
I'm going to be your instructor
times-
for your online class this month.
We don't know the
I
acceleration.
wanted to take a moment to say hello and prove that there's a real person
we
behind
don't
all
know
those
the-
emails
we
and
don't know the acceleration.
discussion
We don't know
posts
the
you're
two
going to be
velocities.
reading
It's
for the
just
next 4
formula
weeks.
for acceleration.
So,
instead of just
let me tell you a little bit
inserting
about myself.
A, we use M times
I grew up in Arlington,
the
Texas,
formula for
which is between
acceleration. So
Dallas and
V3
Fort Worth.
minus V2.
While I
So
was there, I
V3
went to
will
the
be the
University of Texas at
third
Arlington
velocity or
and got
final
my
velocity,
bachelor's degree
which
in
comes to a
physics.
stop. So that
While at
V3 will be
UTA,
0.
I got to work with 2 different physics research
So what are we
groups.
solving for here?
The
We're
first
solving
one was
for
over
force. So
negative
V3,
index
so we have the mass,
refraction,
V.
which are materials
We
that
have
have
the
really
final
weird
velocity, V3,
optical
that's 0.
properties.
That's when she
For
comes to a
instance,
stop.
if you stick a spoon in
And
a
then
normal glass of
V2,
water,
that's
you
the
get an
that's
image
your
that
that's your
looks like
velocity
what's
when
on
she
the
makes
left.
contact with
Well, if you fill the
the
glass
web.
with a negative
And we
index
know
of refraction
part
material,
of one of our
you
assumptions
get
was
the
that
image on the right.
she comes
This
to a
is the
stop
kind of
at
thing they use to
0.5
make
seconds. So that's our change in
invisibility.
time. So that comes
I
out
also
to
spent
a
a
force
year
of
researching
5,194
which are really
newtons.
small
Okay, so
spheres.
to translate
You
that
can
into
adjust their
American,
size to
that's
change what
1,180
color
pounds of force.
Those will be primarily used
Okay, so
for
it took 1,180
displays
pounds of force to
and
produce
even
this.
fighting cancer. After graduating,
Okay,
I started
and
attending
yeah, it
another
says
university
here
in
in the
Waco,
actual
Texas.
comic book,
There I started working
a
on
note
my
on the
master's degree.
letters page of the Amazing Spider-Man.
While
It
there,
says
I
to
used
say that
this
the whiplash
machine to
effect she
make plasma,
underwent when
which is
Spidey's
the
webbing
state of
stopped her
matter.
so suddenly
Plasma is a
in half a
gas
second.
in which electrons have been pulled away
was in
from the
fact-
individual atoms and move around separately, giving the plasma interesting
So
properties.
that was just meant to be a fun exercise of applying our formulas. Okay, Newton's third law. How is this most commonly stated? Every action has an equal and opposite reaction. You've heard it stated that way. Okay. So that's not the complete way of putting it. Basically, that all action that forces occur in pairs, meaning whenever there's a force applied, there's always going to be a reaction force. So you push on the wall is going to push back. Okay, so your an applied force is going to have a reaction force acting back on it. Okay. So whenever one object exerts a force on the second object exerts an equal and opposite force on the first. So forces are never isolated. There's always going to be a reaction force. Anytime there's a push or a pull, no matter what kind of force, there's always going to be a reaction force acting against it. Okay. A reaction force that's equal in magnitude, opposite in direction. So here are some examples of action, force, and reaction. Okay, so a car. How does a car move down the road? Okay, well, we know that the engine turns the wheels, but it's actually the contact with the wheels on the street, on the asphalt, it's actually propelling the car down the road. When you think about a tire, when a tire is spinning, say a tire is spinning clockwise, when it makes contact with the road, it's actually, the tire is moving this way. So it's applying a leftward force on the road. And what's the road doing?
It's applying a rightward
It's
force.
applying a light. So the road is reacting. The reaction force from the road is to the right. Yeah. Okay. Or a rocket. How does a rocket go up in the air? Okay. You see that it's forcing exhaust, a high mass, a lot of exhaust, a lot of mass downward, very, very fast. Okay, with high velocity downward. So it's forcing mass downward, and the reaction force is upward. Okay, so it's pushing. The reaction force from Newton's third law is what lifts a rocket off a pad.
Hello, and welcome to physics. I'm your
No, it says 2 goes on break. Watch that video.
Okay, what about this one down here? When you throw a ball, when you drop a ball off of a tower. Okay, well we know that the Earth's gravity is going to pull on the ball. But did you know that the ball pulls up on the Earth? Okay. All right. So So both forces are equal but opposite. Okay? MA equals MA. Okay. The difference is this. The difference is in the masses. Okay. The mass of the ball is minuscule. It's infinitesimal compared to the mass of the Earth. Okay. So there's an imbalance. So that means that the acceleration. Remember, mass times acceleration equals force. So the acceleration of the ball is going to be large, but the acceleration from the force of the ball on the Earth is going to be infinitesimal. It's going to be almost nothing. Okay, so what about if I push something? If I'm pushing on a chair, I push on this chair, right? The chair is pushing back on me with an equal force. Why is the chair moving and not me?
You have more friction?
It has to do with friction, yeah.
Pushing off the ground too.
Pushing off the ground because, okay, so my friction from my shoes to the ground is basically tethering me to Earth. So basically, I'm acting with the mass of the Earth, and this just is the mass of the chair. And now, if I was not tethered to the Earth, if I did not have the mass of the Earth behind me through the friction, if I push on an object, am I going to move backward?
Yeah.
I am. Yeah. So if you're in space and you push, and you're not tethered to a big mass like the Earth, if you push on an object, both objects, they're going to have both. You know, if they have different masses, they're going to have different accelerations, but they're both going to move. All right. Okay, so this is the last slide for the first part of our lecture. It's a little problem. So this is a good problem you know what? This marker is not good enough for this. So we will do this on the back end of the lab. I need to get a good marker because I got to do a lot of writing. So let's start the lab right now. Do the projectile motion lab. So let's do that. And I'm gonna go find out.
I'm your instructor, Jay Murphy, and I'm excited to introduce you to this course. In this course,
Recording
we will
stopped.
explore fundamental physics concepts using calculus-based mathematical models to describe real-world phenomenon.
Yay!
You will learn the physical
Calculus.
formulas for motion, forces, energy, electromagnetism, and circuits, and how to later apply them to predict real-life outcomes. With this mathematical understanding of physics, you will evaluate computer simulations, as well as design and run your own hands-on experiment to strengthen your problem-solving skills. This course will help you develop several different abilities and skill sets. You will apply laws of motion, forces, and energy to explain natural physical processes. Combine knowledge of algebra and calculus with principles of physics to compute solutions to physical problems. Practice making observations, collecting data, and interpreting results to test ideas and hypotheses. And finally, you will learn to identify physics principles in the world and their impact on everyday life.
Okay, so
During your time in this course, you will have diverse types of learning experiences. You may also
This
see
one can be
different
pretty involved. Let's
faculty
give you
and
45 minutes
presenters
for
in
this.
various lectures or videos within the curriculum. These subject matter specialists are here to help enrich and expand your learning in this course. Your assigned instructor is here to support you through this curriculum. Please refer to their contact information and view the Meet Your Instructor video in the LMS.
So you guys
Reach out to them
all,
anytime you have questions or need assistance.
start the second
On
part
behalf
the
of everyone at Full Sail University, we are so glad you're here. I am looking forward to helping support your goals, and I know you will do great things.
That is subject matter
O'Reilly. The online bookstore. Or beautiful shit.
That's 8 times 2. I think it goes up to 16 times. I think that's the maximum speed for the game. It's like no one.
Working on what, lab 2 he said? The fuck is lab 2?
Hello everyone, welcome to Physics, or Gen 262. My name is Jay Murphy, I'm the course director, and I'm going to do a quick lecture talking about the syllabus and give you a quick introduction to the class. So I want you to know exactly what I expect you to do, what assignments you're going to need to do, and then you can get an idea of what's coming up over the month. So let's start with talking about the grade breakdown. So we have a variety of different assignments, and we can see how much they're going to play a role in your final grade. First, we have practice problem assignments. There's going to be 4 of those, one each week. Each one is worth 4%, totaling 16% of your final grade. There's going to be a total of 10 labs spread out over the 4 weeks. They all have values around 2 to 3 points each, so those total to be about 27% of your final grade. There are 4 tests, one each week, each of them 10%, so total 40%. There's one video project that's going to be at the end of the class. That's going to be at 5% of your grade. You have 10% from your professionalism or GPS, and then 2% for a quick syllabus quiz that's going to happen basically right now at the very beginning of the week. So that's the total breakdown of the class. So let's look at how classes are going to go, or this class is going to go each week. The general flow each week is going to be exactly the same, with just a few little changes here and there of some additional work thrown in. So one of the first things you should do at the beginning of each week is open up all of the different simulations or lab assignments and make sure the simulations actually run. So these simulations are going to require you to open up some different small programs in your browser, and you're going to be playing with those while answering some multiple choice questions. So go ahead and open up those assignments, find those links and click on them and make sure they actually run for you. If you're having any technical issues getting them to run, you want to let me know or let your instructor know as soon as possible so we can help you get them up and running. You don't want to be waiting till an hour before the assignment's due. Click on the link and then have some technical issue and try to figure it out then. So just go.
One day I'm gonna turn my damn alarms off that constantly go off at 9 o'clock in the morning for no fucking reason.
We'll get those up and running as soon as possible. So once you get that technical issue out of the way, you'll want to start working on that week's material, which you'll just want to start reviewing the material. So there are lectures recorded, available to you all of the time. So go look through and watch those videos. So as you're watching those videos, you'll want to take some notes. It'll help the material stay in your mind a little bit better, help you learn it a little bit better, as opposed to just relying on watching the videos and downloading slides. I do have slides available to go with those lectures. I'd also recommend, whenever you're going through the videos, to not only as you're taking your normal notes, but also somewhere on a separate sheet of paper or a different part of your notebook to write down any important equations that are talked about in the lectures. It's usually most students find having an extra cheat sheet of just a long list of useful equations are very helpful when it comes time to work on practice problems and work on the tests. So those notes, very valuable. Now, as you're going through and doing those lectures, you'll notice that after the individual lecture videos, I recommend some practice problems that you can go ahead and start working on, and also some of the labs that you might want to do at that time. So instead of watching all the lectures at once and then start working on the problems, I recommend watch some lecture, work on some problems, maybe do a simulation, go back to another lecture video, more problems, more simulations, and kind of break it up that way instead of doing everything all at once. So throughout the week, you'll want to be doing kind of bouncing back and forth between practice problems, simulations, and watching those lectures. All right, so again, these practice problems and labs, you want to work on them throughout the week. Don't wait to the very end, and particularly the practice problems because they take a long time to work on. So it's only one assignment each week, but plan on spending 3, 4, 5 hours working on these problems. Some of them can be pretty tricky. This is not something you're going to do in 45 minutes. So let's look at how these problems kind of work. I'll go in more detail in a bit, but in general, the assignment themselves just looks like multiple choice questions. So you'll be answering those multiple choice questions, so it seems like it should be very fast, but really each one's going to take quite a bit of time. You're going to be doing quite a bit of math in order to get down to what the answer actually is. Now, it's okay if you really struggle with some of them and are not able to answer them and get them wrong. You'll see why that turns out to be okay in just a minute. But as you're working through them, if you find yourself struggling, go back and look at lectures. You can ask questions on Discord, or probably the best option is to come to some of the many Zoom sessions that are available all the time to jump in and ask questions. You can also ask questions during some of the live lecture periods. You can either come on campus if you're a campus student, or you can come to the live sessions that will be streaming through Zoom as well and ask during those periods as well. Alright, after you submit the multiple choice practice problem assignment, then you will immediately be able to reopen it and see which questions you got wrong, what the correct answers are. You'll also be able to get some hints on those different questions. So if you got them wrong, you can see some hints in order for you to attempt to rework those questions.
He just said when they were all due too, and I wasn't listening. What the fuck was the question that he asked? I didn't hear what you said for this. But you turned in corrected work. Corrected with us. Say something with that week's test, I guess. I don't fucking know. Yep, okay. We guessed right. We're already watching this.
Hello, practice problems and work on the tests. Learn it a little bit better as opposed to just relying on watching the videos and downloading slides. I do have slides available to go with those lectures. I'd also recommend whenever you're going through the videos to not only as you're taking your normal notes, but also somewhere on a separate sheet of paper or a different part of your notebook to write down any important equations that are talked about in the lectures. It's usually most students find having an extra cheat sheet of just a long list of useful equations are very helpful when it comes time to work on practice problems and work on the tests. So those notes, very valuable. Now, as you're going through and doing those lectures, you'll notice that after the individual lecture videos, I recommend some practice problems that you can go ahead and start working on, and also some of the labs that you might want to do at that time. So instead of watching all the lectures at once and then start working on the problems, I recommend watch some lecture, work on some problems, maybe do a simulation, go back to another lecture video, more problems, more simulations, and kind of break it up that
Bro,
way.
it is so wild, dude. This dude right here is not doing
throughout
any.
the week, you'll want to be doing kind of
He's
bouncing back
literally
and
just been
forth,
watching anime the whole
between
time.
Practice problems, simulations, and
There's a lot of
watching
people
those
just kind of
lectures.
bullshitting, it seems. Like, he just
All
does
right,
not give
so
a
again,
fuck,
these
bro. He
practice
must have done all his
problems
shit already
and
or
labs,
something.
you want to work on them throughout the week. Don't wait to the very end, and particularly the practice problems because they take a long time to work on. So it's only one assignment each week, but plan on spending 3, 4, 5 hours working on these problems. Some of them can be pretty tricky. This is not something you're going to do in 45 minutes. So let's look at how these problems kind of work. I'll go in more detail in a bit, but in general, the assignment themselves just looks like multiple choice questions. So you'll be answering those multiple choice questions, so it seems like it should be very fast, but really each one's going to take quite a bit of time. You're going to be doing quite a bit of math in order to get down to what the answer actually is. Now,
Man, I want to start
it's
playing some
okay
more
if
Valve.
you really struggle with some
playing
of them
some
and are not able to answer them and get
Maybe
them
we'll play
wrong.
that during my
We'll
little
see
hour
why,
break or something.
that turns out to be okay in just a minute. But as you're working through them, if you find yourself struggling, go back and look at lectures. You can ask questions on Discord, or probably the best option is to come to some of the mini Zoom sessions that are available all the time to jump in
Me in
and
right
ask
now, baby.
questions. You can also ask questions during some of the live lecture periods that you can either come on campus if you're a campus student, or you can come to the live sessions that will be streaming through Zoom as well and ask during those periods as well. All right. After you submit the multiple choice practice problem assignment, then you will immediately be able to reopen it and see which questions you got wrong, what the correct answers are. You'll also be able to get some hints on those different questions. So if you got them wrong, you can see some hints in order for you to attempt to rework those questions. So try to do them again. Rework all the problems, all of them that you got wrong. Now that you know what the correct answer is, it might give you some hints on where to start. The hints themselves will help you out. And if you're completely unable to solve the problem, you can even open up a solutions document that will then become available at the end of the assignment, which will give you step-by-step solutions to help you try to rework the problem so you can write it out. So in the end, you should be able to have completely written out step-by-step solutions on how to do every single one of the problems, which you'll want to have because then you can later submit those reworked questions in order to get your points back on the practice problem assignment. So there's really no reason why you should not get 100 on each of the practice problem assignments by reworking all of your missed questions and submitting those. Those will be submitted with the weekly test. So the tests are going to be open for 1 day, and by default they're set to be open on Sundays. So that should be the last thing you do for the week, is to take that weekly test. So let's look at all the individual assignments. As I said, we have lectures that are a collection of recorded lectures and slides that are available to you all the time. So as soon as Monday rolls around, you can start working on those videos. Work on the practice problems in the labs as you go along each of those videos, and start early. You don't want to wait until Friday or Saturday to start looking at these videos. It's way too much information in a short period of time. You're not going to have a chance to have it sink in. Alright, so the labs and simulations, they're short activities.
I got a wall built over
primarily here. There to help you visualize some of the equations and some of the topics that we're going over that week. They're not designed to be particularly hard, but you are going to give you some things to play with, allow you to do some hands-on kind of work, since I'm not able to send you hands-on equipment to do hands-on lab. This is the next best thing. So they're going to cover lots of different topics like motion, buoyancy, circuits, or even some electromagnetism, all sorts of fun different topics that you'll be able to play around with. Most of them you have done in 20 to 30 minutes, if that long. So they're not designed to be particularly hard, just designed for you to get some kind of hands-on or visualization to go along with all the math that you'll be doing in the class. Alright, so I'm going to emphasize this one more time, how this practice problem assignment works, because I'm afraid that I don't want it to be tricky and for you to be confused. So practice problems assignment, for each one 4%. The assignment themselves, the original assignment is due on Saturday. Most of the other assignments are going to be due on Sunday, but make sure to note that these will be due on Saturday, and that is where you need to do the multiple choice answers to all of the different questions. So that needs to be done at least by Saturday. I really recommend having it done by Friday. As soon as you submit it, you'll have access to the answers and the hints, so you can start reworking all of the problems that you got wrong. And that might take some time. So if you submit the multiple choice questions on Saturday night, then on Sunday you're going to have to finish up all the other work. You're going to have to rework any of your missed practice problems, and you're going to have to do the test all on one day, which is a whole bunch of stuff. So really don't wait till Saturday. You're really kind of behind if you wait till then. So once that multiple choice is submitted, you have your hints. So go ahead and rework all of your missed questions. Try them again on your own. Don't just look up a solution. Try to figure it out. That's your best bet to learn the material the best way as possible. And then all your reworked problems you'll be submitting with the test. So to submit them with the test, you'll notice that there's a place on the test for them to be submitted, and you'll be submitting either a picture or a PDF or a scan of your worked out problems. So I want to see all the work, how you got to that correct answer that you now know is the correct answer. Any problems that you rework, I will give you those points back for the practice problem assignment.
Okay,
Now,
so
we
you
do
have to
a
turn in
textbook
like
in
the
the
actual
class.
writing
You're
of your
not
work.
required
if
to
you
do
wanna
any
that, if
reading
you have
from
to
that
do rework
textbook,
stuff,
but it's a
got it.
good resource if you want to go look some stuff up. It's called Fundamentals of Physics by Walker, Resnick, and Holliday. You can find it by going to ebooks.fullsail.edu. You also find that link scattered around throughout the class as well. But you need to go through it if you go through this link to get to it, then that will have you sign into the O'Reilly using your Full Sail credentials, so you'll have access to the book. Alright, so the weekly tests, as I mentioned, these are by default going to be opened for 24 hours on Sunday. So that one day to do the assignment. Now,
Okay.
it should only take you about 1 hour to do it if you know what you're doing. So if you actually understand the material, an hour should be more than enough time to complete it. If you don't really understand the material and you have to spend the whole time trying to look stuff up and rewatch videos, it might take you significantly longer than that, but if you're prepared, that shouldn't be an issue. Okay. Now the assignment
shall be
consists of multiple
prepared.
choice and free response style questions. So by free response, I mean you'll be able to just type in what your answer is going to be. It's not like a multiple choice to pick an option. So it's about a third multiple choice. So and those are mostly kind of conceptual questions. And then the free response questions are the ones that are going to be very similar to the practice problems, but instead of having multiple choice answers, you're just going to be typing in what your answer is going to be.
Over here. Somewhere right. I
You
guess
want to
right
have
here.
everything done before taking this test. You don't want to, if you wait to do a lab or work on some practice problem reworks until after you do the test, then that's stuff that might have helped you do better on the test. So go ahead and try to have that be the last thing you do. Now, as part of this test, you're going to have 2 free response questions, but they're going to have multiple parts, like A, B, C, D, E, and so on. A lot of times, your answer for part B is going to require you to use your answer for part A, and your answer for part C might require your answer for part B or part A. Not every time, but this happens quite often. So because of this, if you get your answer to part A wrong, I will use your incorrect part A answer to calculate what your answer to part B would be if your answer to A was correct. So missing part A does not prevent you from getting the rest of the problems correct. So any mistakes you make, I will carry on through that test question. So you don't need to worry about making one mistake and having that one mistake make you miss all the rest of the questions. Now, you do have 1 day to take this test. As I said, it should take less than an hour, and it is set to be on Sunday. If you would like it to be on
Where
a
it'd be the
different
other
day,
wall,
like
and that's
move it
got
up
to
to
light up.
Saturday or
That's want to
Friday,
like light up
like your
all of this
Sunday is too
area. The
busy,
thing
you
I'm
don't
like
have
dig out a
time to
trench
take
from
that
this
hour
wall to
work
the
on
other
it.
wall.
You need to
It's just
contact
kind
your
of filled with
instructor
water and stuff.
with a couple
Keep
days
different spawning
notice,
coming
and we
over
will
here.
move the test up for you to a day that works better for you. Just let us know. We have no problem moving that test up to a different day if Sunday is
Up
not
there,
a
I
good
don't
day
know.
for
Fuck,
you.
something
That's
up
not
there.
an issue.
Whoever gets on.
Alright, there's a few other small miscellaneous assignments that don't really fit into the general lineup of the assignments. So normally everything's open on Monday. Everything will be due on Sunday except for the practice problem. Originally, those are due on Saturday instead. So difference is, this first week we have a professionalism assignment. It's due this first week. It's just looking at the same professionalism guidelines that you have in all your other classes and check, yes, I have actually looked at this. There's not many ways you'll lose points for professionalism in this class, but things like repeatedly turning in assignments late will have points taken off. if you have one assignment that's due late and you need to get an extension, that's not a big deal. If it turns into something that happens repeatedly, then you'll start losing points off your professionalism for that. Unprofessional communication, that kind of thing, you'll lose some points. But this is the same kind of thing that you have in all your classes. There's a syllabus test that's 2% of your grade. This is going to be due on the 3rd day of the class. This is Wednesday, so it happens very quick, but you should be able to do that immediately following this little short lecture. And it's just basically reinforcing all the stuff that you should already know from watching this video. Then finally, we have the video project. This is going to start on week 3 and is due on the last day of the class. So this one's open for 2 weeks. It's a short little project where you'll basically be choosing a physics topic, explaining that topic, and doing a short 2 to 3 minute video demonstrating that topic with some kind of experiment. So you'll get to do some little short experiment at home. Right? It's not a big deal. Don't worry about having it look super amazing or having a nice camera. People do this with their webcams on the laptop or using a phone all the time. So don't get too stressed out about it. But you'll get all the details on that at the beginning of week 3. Of course, I've already talked about all this. So we'll just move on to a little bit about the class in general. So of course, this is a physics class. So we're looking at kind of the physics as being an explanation on how the universe works. So this is laws or equations or concepts that apply to big things like the universe or the galaxy, why the galaxy shaped the way it is, that kind of thing, to everyday sized objects. So if you throw a ball, where's that ball going to land? To really small things like atoms and subatomic particles. All these things fall into physics. So it's an important topic to have a good foundation on that you can build on in the future if there's particular areas you need more knowledge on. But we're going to get a good foundation of motion and collisions and energy, and then we'll talk also a little bit about circuits and electromagnetism and rotation and stuff towards the end. So we'll get a good foundation of basic physics. We will be using the metric system in the class instead of like the English system. We do that for a few reasons. One, it's what most of the world uses. So because physics is an important topic that is studied all over the world, and communicating with cohorts across the world is an important facet of physics. Then in general, physics sticks with metric so we can communicate with people across the world much more easily. And of course, it's also significantly easier than the English system with its odd numbers of 1 unit converted to a different unit, like 12 inches to 1 foot. So if you're not super used to the metric system, you're going to be okay. We're not going to be doing really any much in the way of unit conversion. And if you need to do any unit conversion, you can always just type it into Google and have it do it for you. But in general, I try to keep everything, for the most part, put in the correct unit so you don't have to worry about conversion. So we're going to be dealing with base units for everything. Here's some of the base units. So we'll be using like meters, second, newtons, joules, watts. We won't be dealing much with like kilowatts or nanojoules or anything like that. We're going to stick with base units to try to keep things as simple as possible, considering we only have 4 weeks for the class.